Did anyone have any questions related to this, what I went through last time? I know it was like a whirlwind thing, and we didn't cover every detail, of course. But did anybody have any questions? Something I really confused you on or didn't cover? Syllabus stuff? I know there's a lot to learn yet about how we're going to do this, but and what I'm doing is I'm inserting one lesson prior to getting into the book. I call it Major Lessons in Statistics. So this is kind of an overarching lesson today of really big things that will apply to the whole semester. So this is pretty important stuff, and it kind of sets the tone. You're going to hear the word context a lot, and I know you know what that word means. C-O-N-T-E-X-T. Context. Is it important, for example, when you're looking at a quote, let's say in a news story, is it important to know the context? Yeah, in fact, out of context, you can almost say whatever you want, can't you? And actually, half the difficulty with false statistics interpretation is not knowing the context. Well, those are interesting numbers. Like you could say, hey, we're up 20% this year. Cool, this is exciting. And you find out that the rest of the industry is up 60. And you basically have been left in the dust. In context it just means so much. So you're going to hear that term come up quite a bit today. But we have some things to look at. First, I collected a few things from the introductory pages of our book, and I thought they were worth mentioning. One of them, Moore, by the way, the author of our text, study of statistics is supposed to help students work with data in their varied academic disciplines and in their unpredictable later employment. Let's face it, you don't know what's going to happen day to day, and you don't know what's going to happen with your job. We're not even completely sure what's going to happen with some of the industry. Who knows? Maybe technology will cause a certain field to become larger or smaller. Anyway, highlighted then, students learn to work with data by working with data. And so this is one of the philosophies of the book. It's kind of like saying to learn statistics, you have to do statistics. And therefore, the philosophy of our book is we're going to kind of get you in with the data doing things. I got good news for you. I would say about 98% of all the data that is used in exercises, I've published on the web for you, so that like if you're going to see a lot of blocks of numbers. Like here's the data the scientist collected when he was measuring the lengths of icicles, and there's this big blob of numbers. They're in a data file for you, so you don't have to type all the numbers in. So at least you don't have to do the grueling, make sure you copy it right. We've got data files for you. So you can load them, and then you can spend your time dealing with the numbers instead of getting them in there. So stuff like that will be nice. But anyway, this book has a pretty big emphasis on you guys actually getting in there and doing stuff. Data are more than mere numbers. Here we go with that context. They are numbers with a context that should play a role in making sense of the numbers and in stating. So, this is listed as a mathematics course, but this context is telling you got to use your noggin and just use a lot of common sense on problems too. And in fact, take the time to look at the context. Maybe even if it's somebody who's making a claim, ask them some questions about the context so that you get a better feel. And it might even be interesting to see if the person making the claim really knows the context. If they don't, that tells you something about its claims. The third one, statistics more than other branches of math depends on judgment for effective use. So you're actually going to have to sit back and use a little common sense. It's not just all mathematics. Now, statistics can be taught in a lot of different ways. I really like this textbook for making things down to earth. I mean, I'll see how you feel about it later, but my experience previous to, well, an earlier version of this guy's book was not the most, well, first of all, when I was growing up, I used to love kind of keeping track of things, and I would, my dad taught me something called penny baseball, which you can tell it's a guy who grew up in the Depression, and they needed something simple and cheap, and all you need is 4 pennies, a sheet of paper, and a pencil. And the idea is you can make up schedules, which is a little mathematical, and so that each team plays the other team a certain number, an equal number of times, and that each team has an equal number of home and away games, and all that kind of stuff. Anyway, make schedules, and I used to use the Major League Baseball teams, and then the 4 pennies you would take, you take the top, whoever is playing first here, and you basically make believe that every series was a 4-game series. And you take the 4 pennies, and shake them, and whichever team was the home team got heads, whichever team was the away team got tails, and so I'd look, the home team won 3 out of the 4 games. And then, go on to the next team on the schedule. And I would play through seasons like this and see who finished first and all of that. And I was Major League rooting for the Milwaukee Braves, just to show you how far back. And anyway, that was kind of, and I used to kind of like keeping track of stuff, keeping organized, kind of statistics. When I was working on getting my master's degree, I took a stats class that was incredibly heavy on formulas. When I got done, it really didn't feel like I gained a lot. Sure, I was able to use the formulas, but I mean, if somebody asked me what I learned, I really would have had trouble. It just was not a real wonderful experience. I mean, I did all right. I think I got a B, but it wasn't, I don't know, just wasn't that great. When I was an adjunct here, I was asked to teach statistics. This same course, only back about 10 years ago. And they showed me this book by Moore, which is about, two versions before this one. And I kind of fell in love with statistics again, because it was this real practical, hands-on approach. And anyway, this is just a later version of the same thing. It's really, I hope you like it too, but it's kind of like the kind of statistics you come upon in life, not stuff that you only hear about twice and you don't care to hear about it again. And instead of cramming a whole bunch of formulas down your throat, instead we're going to just kind of emphasize more just practical, how do I deal with this stuff day to day? How do I tell if it's the truth? Stuff like that. The last one on the page, a repeat, data are numbers within context. The context engages our background knowledge and allows us to make judgments. So there we are with judgments again. Oh, just a reminder, these slides I can write on, and I will at times, make marks. For example, I might come on here and emphasize something, circle something, right? The reason I do it electronically is so that I can store this, and this is posted on the website, and then I'm recording it. So if you wanna, so you can get the words and this, what you're seeing up here, kind of together. So there will be some resources. You got to give me a little time to process the video. And by the way, I'll put audio out too. So it'll be a little video file if you want to see it. Maybe not so little. Generally speaking, about 30 megabytes. But it streams pretty nicely onto a personal PC. And then I'll also do MP3 if you just to get the sound. So anyway, the first little big lesson, the first lesson today is data beats anecdotes. Now, data is what? That word for, it's the official word for information, numbers, maybe it might be colors. You might have data file that goes brown, green, blue, yellow. It might be it doesn't have to be numbers, but keeping track of things. Anecdotes. Anecdotes like somebody telling you their story, right? Now, take a look at this because I think you will relate to this right away. An anecdote is a striking story that sticks in our minds exactly because it's striking. Anecdotes humanize an issue, but they can be misleading. Does living, here's an issue I'd like you to think about for a few minutes. Does living near power lines cause leukemia in children? Some people suspect that it does. Maybe you've heard maybe you might have even seen, there have been some television specials on this issue. The National Cancer Institute spent 5 years and $5 million gathering data on this question. The researchers compared 638 children who had leukemia and 620 who did not. They went into the homes and actually measured the magnetic fields in the children's bedrooms and in other rooms and at the front door. So I suppose the reason for the front door is if the kids are playing outside, is there an issue outside? They recorded facts about power lines near the family home and also near the mother's residence when she was pregnant. Result: no connection between leukemia and exposure to magnetic fields of the kind that the power lines produce. The editorial that accompanied the study report in the New England Journal of Medicine thundered, "It's time to stop wasting our resources on this." $5 million they spent, and this guy in the New England Journal of Medicine said, "All right, let's let this issue be. Let's spend money on other kinds of research." Now, compare the effectiveness of a television news report. You can just picture popular local news reporter. You know how they go out in the community and they talk to people. Television news report of a 5-year, $5 million investigation against a televised interview with an articulate mother whose child has leukemia and who happens to live near a power line. In the public mind, the anecdote wins every time. You see this mother talking, and she might even be crying, and you can understand why. This terrible thing has happened, and sure enough, you look up, the camera pans up, and there are the power lines. That's powerful stuff. People see that and they go, it causes leukemia, even though the data said it doesn't. So the story, that video is powerful, especially, you can imagine, especially this woman's and this kid's life have been torn apart. That touches your heart. Okay, now as a statistician, I'm not telling you not to use your hearts, but you really should look at the data. You can't tell by one incident. That's why they compared 1,260 people to get a... is that everybody? No, but that's a lot more accurate than one. And even though this mother probably thinks that's what happened, it's hard to get yourself in a neutral position to make a judgment. So anyway, use your judgment, but you really need some strong numbers that pretty much demonstrate something before you come to any definite conclusions. The second one I'd want to bring up today is, you're going to hear about this a lot in this course, lurking variables. You know, you got to be aware of this. You can walk around a corner in the math building, there might be a variable lurking at you from behind the trash can. I know, I'm just kidding. But in a way, they're kind of like lurking in the background, and you can't see them. And here's really a good example, I think. The Kalamazoo, Michigan Symphony once advertised a Mozart for Minors program with this statement. Question: which students scored 51 points higher in verbal skills and 39 points higher in math? Answer: students who had experience in music. Wow, that's pretty strong stuff. And by the way, those numbers are actually accurate. Now, the average Joe goes, holy cow, music increases your intelligence. We don't know that. And here's kind of a lesson that we're going to be learning this year. Just because two things seem to happen together doesn't mean one causes the other. Okay? And that's a real easy one to hop onto. Now, I still think music is really good for people, but I wouldn't go as far as saying causes, okay? And do you see how they're kind of leading you toward, oh man, get your kid in music, he'll be smarter. It's almost like what they're saying. Who would dispute that early experience, by the way, some people even play classical music to the cribs. And in fact, some do it to the womb of a pregnant mother. And by the way, we know that they can hear. And so the idea is certain kinds of music seem to help your brain get organized more and get set up. Anyway, it seems that way. So who would dispute that early experience with music is good for you? The skeptical statistician. That's who. Children who take music lessons and attend concerts tend to have prosperous and well-educated parents. These same children are also likely to attend good schools. They probably get good health care, and they're probably encouraged by their parents to study hard. Come on in. You made it. Traffic was pretty bad, huh? Thanks for calling again. So anyway, do you see the problem here? Sure, the kids that had music did better, but those kids that had music probably also were in soccer after school, probably had a pretty nice home environment, probably were not, wondering if they'd get their next meal. They were, generally speaking, pretty well cared for. So was it the music that was causing all of this, or is music just one sign that the parents took a pretty active role in their kids growing up? Probably the latter. The children's family background is a lurking, so their home life and their family background is, in this case, is a, I should circle or highlight that here, is a lurking variable. So there's a good example of a lurking variable. It's lurking behind the scenes, unmentioned in the symphony. The symphony doesn't say, look at the kids who have caring parents do well in their math scores. No, they're going to say the kids who take music do. And they're not lying. It's not wrong. It's just that you've got to be careful not to jump to a conclusion. Perhaps the Kalamazoo Youth Soccer League should advertise that students who play soccer score higher on tests. You know what? They probably do, for some of the same reasons. After all, children who play soccer, like those who have experience in music, tend to have educated, caring, prosperous parents. The message is worth repeating. Beware the lurking variable. And that means when you're looking at situations, you almost have to, think a little bit about the lurking variables that might exist there. And again, aren't we really just talking about context? Okay. The third item we're going to look at today is called Where the data comes from is important. I should have stated it the way it is here. Where the data by the way, the word data is actually plural. And that's why come is correct. The singular is datum, D-A-T-U-M. We don't use that very often. Actually, the word data is a plural. So if that looked a little unnatural, you know, I even tripped on it. I said where the data comes from. I was wrong. It's where the data come from is important. Okay, this is an interesting one. I don't know. You guys know who Ann Landers is? She's still around, right? I guess. And I guess she writes articles in what? Does anybody know? Is she in the Milwaukee Journal? Did she? How long ago? Okay, a little. So she's not around anymore. Well, anyway, she had an article in a lot of major papers. The advice columnist Ann Landers once asked her readers, "If you had to do it over again, would you have children?" A few weeks later, her column was headlined, 70% of parents say kids not worth it. Whoa. Now, what do you think happened there? Do you really believe that 70% of parents would not have kids again? I don't. And see, here's the problem. When you do a survey of some kind like this, who are the people that are most likely to come out and answer the survey? It's almost every time it's the negative ones. Okay? It's just a fact of life. People who are happy, well, I don't need to fill out a survey. People who are ticked off, give me that survey. I'm going to blast it, you know. And that's exactly what happened. And so we call that a convenience sample, when they just take whoever, this is the problem with internet surveys too. Internet surveys, the people who generally respond on a positive negative issue, most of them are going to be negative. I don't know, they're in a fighting mood, you know, and they want to have some action. But if you're having if things are going well for you, have you ever, you know, how many times isn't that the case? If you're really happy with something, do you always tell the person? Probably not. If you're ticked off, you're more likely to say something about it. So anyway, actually 70% of, this is a big sample too, 70% of 10,000 parents wrote in, said they would not have kids again. So 7,000 out of 10,000 people said, no way, I don't want kids anymore. And you shouldn't believe this, because the people who took the trouble are not, that should be not nor, are not, I'm going to change to a pen here. Where is that? Are not representative of all parents. Their letters showed that many of them were ticked off at their kids. All we know from these data is that there are some unhappy parents out there. A statistically designed poll, one that's really careful about not having bias in it, was done. And guess what? In this really good, carefully designed poll, 91% of parents said they would do it again. So talk about a complete reversal. So you got to watch out for, where did you get your data from? You know, it's like the all too typical 9 out of 10 doctors recommend. We hear that just about daily, don't we? Something similar to that. Have you ever heard anybody going, hey, 2 out of 10 doctors recommend our medicine? Yeah, right, they're going to put that on the air. And so, yeah, well, that's good that you have 9 out of 10. Can you tell me a little bit about where you got your data from? Of course, you can't talk back to a commercial. But that's what I'd really want to know. Where did you get... You never know. They might have just taken 10 doctors and put down what they said. And there are all kinds of shenanigans here. Like sometimes if they ask people and they answer the wrong thing, they say, oh yeah, I didn't really ask him. I'm not kidding you. They will actually keep asking until they get the responses they want. And that's not all. Some of the people who said yes took a payment, which of course is totally unreal. So there's all kinds of junky data out there, and you really want to try to find out about it. Okay. Variation is everywhere. I'm going to try to make the point here. I like this. I'll just read the paragraph because it kind of sets the stage real nicely. The company's sales reps file into their monthly meeting. They come into the room. The sales manager gets up. Congratulations! Our sales were up 2% last month. So we're all going to drink champagne this morning. You remember when sales were down 1% last month and I fired half our reps? Okay, now what do you think about that? Just a little bit reactive here? If your sales were down 1% and you were in charge, would you fire half your sales representatives? I hope not. 1% is such a tiny amount. It's almost like saying sales were pretty even. And then it goes up by 2% and you get real hyper and you go, yoo-hoo! And you give champagne to everybody. I hate to say this, but data has natural variation to it. Okay? Why might it be down 1%? Who knows? Maybe there were extra holidays during that month and they had a little bit less chance to meet customers. Or it could be that the weather was so lousy that people didn't have as much time to be interested in buying. Or, it could be lots of things. But variation is natural. So it says here, the picture is only slightly exaggerated. Many managers do overreact to small, short-term variation in key figures. And I like this quote by Arthur Nielsen here. He says, too many business people assign equal validity to all numbers printed on paper. That's on paper, not an. They accept numbers as representing truth, right? Sometimes when people see numbers, it's like, holy cow, this is practically from God himself. It says here, 17,248 people bought this item using the internet. And they're like, wow, that's exact. It sounds so authoritative. Yeah, but you don't know all the context again. And so sometimes we put too much weight into all of that. So then it says they find it difficult to work with the concept of probability. They do not see a number as a kind of shorthand for a range. So anyway, here, this is a graph that shows what? This is gas prices, not recently, but gas prices is always a good issue. It's a hot one, and it's one that we're not real thrilled about. But you notice some things going on here, okay? When the Gulf War started, there was a blip going up. Because right away, when you have a war, you use a lot of fuel. It's going to cause a little bit of a shortage, and the prices are going to go up. But you notice it didn't just go up, it then came down, and it blipped up again, and you have this natural needle hopping, if you will, this natural variation. And then, when there was a real strong chance there was going to be war in the Middle East, this is a few years ago, 2003. So anyway, but the point is, yes, there are blips. Yes, they probably are caused by real things. But there's all these little variations. So, if this goes down just a little bit like it does right here, I hope you don't go out and fire all your employees because you went down 1%. You really do have to be able to roll. There is some natural variation. Okay, enough stated. Yeah. Maybe this is what they should do at the gas pumps. I kind of like that. Or let's see. What could I get for an ear? No, hope we don't get to that. Here's another one. Conclusions are not certain. Boy, and this sounds like I've just committed the greatest mathematical sin anyone could ever commit. I'm saying in statistics class, no, conclusions are not, it's like, when in math have you had 6 plus 3 is 9? I'm absolutely certain of that. Well, in statistics, almost almost all the time we're talking in terms of probability. You're going to hear us say things like, well, there's a 95% chance that this was caused by that phenomenon. Instead of, I'm absolutely certain this was caused by that. So if that bothers you, it's going to be a little uncomfortable for you. We've always got a little bit of uncertainty in statistics. Okay, most women who reach middle age have regular mammograms to detect breast cancer. Do mammograms really reduce the risk of dying of breast cancer? To defeat the lurking variable, doctors rely on experiments called clinical trials that compare different ways of screening. The conclusion from 13 such trials is that mammograms reduce the risk of death in women aged 50 to 64 years by a pretty substantial amount, 26%. So, on the average then, women who have regular mammograms are less likely to die of breast cancer. But, because variation is everywhere, guess what? The results are different for different women. Some women who have yearly mammograms, I hate to say it, still die of breast cancer. And some who never have mammograms live to 100, and instead of dying from breast cancer, they maybe die in a motorcycle crash. The point is there's variation. Statistical conclusions are on the average statements only. Well then, can we be sure that mammograms reduce risk on the average? I'm sorry to say this, but the answer is no, we can't. And we can be pretty confident, but we could say, yeah, I'm reasonably sure it reduces, but we can't be absolutely certain. So this is a little bit uncomfortable because I'm normally, but I just got to tell you, statistics are kind of on the out in math departments. In fact, in a lot of schools, they refuse to say that statistics is part of the math department. This is kind of hilarious. It's almost like, you can't be part of our club. I taught at Minnesota State University in Mankato, and there they call it the Department of Mathematics and Statistics. So it's kind of actually hilarious. So it's almost uncomfortable for me to say here, and I normally teach math courses. I have to say to you, not all conclusions are 100% certain. Wow, is that different for a math teacher? And it's kind of weird. Anyway, so by now you got the picture. Context is huge, isn't it? And I just tried to come up with I got a couple slides here to illustrate context. And if your context is different, my goodness, you can come to totally different conclusions. You can see a picture here of, if you look in the circle, he's looking at just that little amount of data. But if he looks at his whole screen, he gets more of a view of what's around it and how the whole thing looks. Okay, take a look at this picture. Okay, it looks to me like you're actually within the legal observation zone here. Maybe you're a NASA employee and you're observing something important and you're watching the shuttle launch. Okay, you're probably really concerned about, are there any insulation things dropping off? Are there any fuel leaks? Are the astronauts safe? Things like that, right? Okay, now here's a slightly different context of the same thing. I shouldn't have said slightly. I don't know. Can you see it? It's maybe too tiny for you. But here's the launch. Here's the vehicle. Okay. Now we're obviously up in a very high altitude vehicle of some kind, looking down. Now you have a totally different context, don't you? Maybe from here you're thinking, wow, the weather is pretty good in this area. It's a good day for launch. I'm not maybe thinking about the astronauts quite as much. I'm wondering, are they on the right angle to get into orbit? Boy, it sure changes your perspective, doesn't it? Quite a bit. Different context. as you can see, that was a launch on September 9th of 2006. Okay, so now I'm going to show you a couple more slides. And I don't know, I guess it didn't need to have that up there, but... Okay, this is a picture taken from 100 millionth of a meter away. Okay, that is, what, 10 nanometers. This is our really high-powered microscope, and it's looking at a strand of DNA. Now, of course, we don't normally have views like that, but there is scientific equipment that lets you look at that. And you can actually see the spiral chains of DNA. And, okay. Now, this picture is taken from the same location, but it's back a bit. This picture was taken from 1 meter away. Okay, so that DNA we were looking at a few minutes ago was in, his hand, in the living material in his hand. Of course, you got to have living material for DNA. Is the context a little different here? I'll say, I think he's got food, he's got books, he's laying on a blanket. By the way, he's laying, I might show you that presentation later. But looks to me like he's having a good rest, and it's just he's not too worried about his DNA. This picture is taken from the same location too, just from a little bit farther away, as in 1 million meters up. Okay, and as you can probably tell, by the way, this guy was laying on a blanket in a park right by the lake shore in Chicago, Illinois. So anyway, now we're back 1 million meters. Is the context a little different? I'm sure not worried about DNA here. I don't even know there's a guy in the picture, do I? I might be worried a little bit about Chicago pollution, which you can actually see. You see, well, you can't see it real well, but there's a lot of junk, and even the water is affected here. A lot of that comes from not just Chicago, but Gary, Indiana, which is right here on the bottom. And Gary, Indiana, for years, was steel making, and it's the only place I've ever been to that has black grass. It's a lot of big-time industrialization problems. But anyway, let's back up a little bit more. Okay, now we're 100,000 light years away. Same view. Is your context a bit different? Oh my. By the way, that beautiful spiral thing there, that's our home galaxy, the Milky Way. And so I'm trying to just emphasize context is incredibly important. And we'll even go out one more. This is the farthest distance picture that's ever been taken. It's actually a famous picture. It's called the Hubble Deep Field Image, taken by Hubble. Actually, I think it's like 250 pictures that were digitally combined to get the color and everything. And just about everything. So now we're, 10 billion light years? You guys know what a light year is? It's the distance, and it's how far light can travel in a year. Which is pretty far because light goes 186,000 miles a second. Now do that for a year, and that distance is a light year. Okay, now go out 10 billion of them, and you're looking back at the Earth. Okay, different context, yeah. Just about every bright spot is its own galaxy. And so anyway, context. All right. So I've given you what? I hope not too many, but just a few major things to kind of keep your mind on, and will shape really. You'll hear these themes come up several times. This is where we're headed on Friday, and I'll give you your first assignment. Is to get ready by doing some reading in Chapter 1. You'll find the chapters are not very long, The other thing I need to tell you or remind you of is that our book is really kind of different in that the exercises are mixed together with the text. You may think that's kind of like interrupting, and I wouldn't be able to argue with you real much. But on the positive side, it's kind of like, well, we've just shown you something. Let's take a look at an example to illustrate it. And can be very good. It's just different. When people sit down and go, well, wait a minute, here's number 1, and 3 pages later is number 2. And it takes a little while to get used to. Okay, so chapter 1 is not real long. It's about picturing distributions with graphs. And that's where I will head on Friday. Anybody have any questions? Maybe what I'll do on Friday is I'll also illustrate how this recording went and play a little section of it just to show you how to access it and so forth. Okay, thanks a lot. You have a good day.